Hello everyone, myself Paula Mokwana, Assistant Professor of PC Department at LJ Institute of Engineering and Technology. Welcome to session of Radar and Navigational Aids. In the last session, we have finished unit number 2, in which we have seen the radar range equation. Apart from that, what do you mean by pulse radar and different types of radar? What are different terms which are related to the radar range, like transmitting power, radar cross section, minimum detectable signal. Alright, so in this section we are going to start with number 3, that is continuous wave and the frequency modulated continuous wave radar. That is the chapter number 3 of radar as per the schedule syllabus. So in today's session we will see, first of all, what are the types of radar? What is the relationship between the range and the power? In which form we are going to transmit the pulse, whether it is a continuous wave or in terms of pulse. We will see the block diagram of continuous wave radar. The most important thing, that is a Doppler shift frequency, alright, which are related to the continuous wave radar. So we will also see the difference between the pulse and the continuous wave radar. Now we all know that there are two types of basic radar. The first one is the continuous wave radar and the second one is the pulse wave radar. We can say that we are going to transmit the pulse in form of either a continuous wave or in the form of pulse, right? So based on the transmission of pulse or based on transmission of wave, we can say that the radar can be classified into two categories. So these are the two basic radar types. Now, what do we mean by pulse radar? So in the pulse radar, it transmits a series of pulse, a series of continuous pulse by a non-transmission interval, during which a radar will going to return a signal. That means it will transmit a pulse and it wait for some time for a reception of echo signal. And after some time, it will going to transmit a second pulse, alright, in pulse radar. So in a continuous wave radar, we can say that it continuously, or means it constantly transmits signal, constantly transmit the wave. So a relative motion of either a radar or the target is required for detection of target. Alright, so it includes the concept of Doppler frequency, or we can see the frequency shift. So these are the two basic types of radar. Now, as we can say that the pulse transmission, what does it mean? So the pulse transmission means, we can say over here, this is the pulse axis, on the axis is a time, and in which we can say that this is my first pulse, after some time it is a resting time, this is the second pulse. So we can say that the radar carrier frequency. So what does it mean? First we are going to transmit the first pulse. The resting time includes the reception of echo signal, which is a signal which is going to be reflected from the target. Second, we are going to transmit a second pulse for the pulse radar. Alright. So this interval from transmission of first pulse to the rest time is called the pulse repetition time. And the inverse of pulse repetition time is called the pulse repetition frequency. Alright. So this diagram shows how we are going to transmit the pulse from the radar antenna. Now, what is the relationship between the range with power, range with pulse width, and the range with the pulse repetition frequency? This is all the definition that we have covered in the last session. That what do you mean by pulse width, what do you mean by pulse repetition frequency, what is PRT, what is average power, what is peak power, what is duty cycle. Alright. First of all, we are going to see the definition of minimum range. That means when a signal is going to be transmitted. If the signal is going to be transmitted, but a return is not received, that means the radar is out of the range, or my target is out of the range of the radar. Okay, that means we are not able to receive the echo signal. So we receive the echo signal only which my target is in the range of radar, and we know that the range is measured in the kilometer. Alright. So a target must be in the range of radar so that a radar is able to detect a target. Alright. So what is the maximum range? So the maximum range, you can say that it is the ratio of average power into peak power. Or you can say that this relation, the ratio of pulse width and the pulse repetition time. And we know that the relationship between the pulse repetition time and pulse repetition frequencies, both are the inverse proportion. Okay. So we can say that pulse width and the pulse repetition frequency both are going to be multiplied, and we are able to calculate the value of maximum range. Right? Now, the pulse repetition frequency means what? It is the pulses per second. That means in 1 second, how many pulses are going to be transmitted? Alright? We are also able to relate the pulse repetition frequency with the pulse repetition time, because PR is equal to 1 upon PRT. So by varying this value, that is a pulse repetition frequency, we can say that we are able to change the value of maximum range and the accuracy of radar. Third, what is peak power? We can say that the maximum signal power for any pulse. That means it is also going to affect the range of radar. Okay, as we know that from the equation of radar range, the radar range is directly proportional to the transmitted power, which is inversely proportional to the minimum detectable signal, that is S mean. Alright, the radar range is directly proportional to the radar cross section. Okay, if the radar cross section is high, then my radar is able to receive the weakest echo signal too. Okay. Now what is average power? So the average power is the total power transmitted per unit of time. We can say that the relation of average power with the pulse width and with the pulse repetition time, as we have seen the formula for the average power and the pulse width. Now what is duty cycle? It is the ratio of pulse width and PRT. So what is pulse width? That means for which time we are going to transmit the signal, or we are going to transmit a pulse. PRT means the time of entire cycle. That means for some period of time we are going to transmit the pulse, and rest of the period is for resting. That means for that period of time we are going to receive the echo pulse. So the whole period, total period, entire cycle, that means my transmitting pulse plus the rest time, the total period is called the duty cycle. That means this duty cycle relates the pulse width and the PRT. Okay, PRT is a total time period and the pulse width is for the time period for which we are going to transmit the signal. So we can say that it is also equal to the ratio of average power to the peak power, right? So these are the terms which are related to the radar range. Why the radar range is most important? Because with the help of radar range, we are able to detect a target. Okay? If and only if that radar or the target is in the range of radar. Alright. Now what are the key points? The key points are, first, by varying the pulse width, that is going to affect the range of radar. Why? Because ultimately, as we are going to change the pulse width, we are going to change its duty cycle. In duty cycle, with the help of change in duty cycle, it also affects my average power and the peak power. And we know that the transmitted power is directly proportional to the radar range. So by varying the pulse width, we are able to change the range of the radar. So if we need to short the range of radar, that what we do is we simply need to short the pulse. That will decrease the range target, the range radar target. Alright. Now what is a pulse width? So the pulse width will determine the radar's minimum range resolution. Right? Third, by slower the pulse repetition frequency, we are able to get the radar's maximum range. Alright? And by faster the PRF, the accuracy is going to increase. So the PRF, by slowing or increasing, we are able to get the maximum radar range, as well as we are able to increase the accuracy of radar. Alright, so these are the key points which relates the pulse width and PRF with radar range and radar accuracy. Alright. Now we are focusing on the first type of basic radar, that is the continuous wave radar, in which we can say that we are going to transmit a continuous signal, continuous wave. Okay, the radar is going to transmit a continuous wave to the target. Alright. So for continuous wave radar, we are going to employ two separate antenna. One is for the transmitting and one is for the reception. Okay. So this is the example of the continuous wave radar. You can see over here. This image represents a continuous wave radar. You can see that there are two separate antennas are there. Okay. One is for transmission, other is for reception. Alright. So when we are going to deal with the continuous wave radar, the most important parameter, most important factor is, we need to understand, is a Doppler shift. So what is Doppler shift? Let us understand first the definition of Doppler shift. Now, this Doppler shift, what it represents. But for understanding the Doppler shift, first we need to understand what is the importance of Doppler shift frequency over here. Okay. So for the continuous wave radar, we need to produce a constant stream of energy. That means there should be a no interval between pulse, because we are going to transmit a continuous wave. Alright. So we can't distinguish a distance, or we can say the range, because there is a no interval between the pulses. Third, we are able to distinguish a moving and the stationary targets with the help of Doppler frequency shift. That means if the value of this Doppler frequency is higher and if it is lower, we are able to say that my target is stationary or moving. Okay, how? We are able to identify whether the target is stationary or moving. So for that we need to understand the Doppler frequency shift. Now what does it mean? See, consider this is a target. Okay, and over there, my radar was there. Okay, radar is going to transmit the signal to the radar, to the target. Sorry, radar is going to transmit a signal to the target, and the signal is going to be reflected back. That is my echo signal to the radar. Okay, but assume my target is moving away from the radar. That means my frequency is going to be decreased. Alright, and if my target is moving towards the radar, it will imply that my echo frequency is going to be increased. Okay, because the target is reached towards the radar, towards nearer to the radar. Okay, so it implies that the frequency is going to increase.